Hey guys, welcome to another video, and today I have a question from random variables. This is from a discrete random variable, Poisson random variable. Let x be a Poisson random variable with mean equal to half. Then we need to find the expected value of x+1 factorial that equals to 2e to the power minus half. Is it 4e to the power minus half? Is it 4e to the power minus 1? Is it 2 times e to the power minus 1? So let's get started. Okay, what is given to us is expected value of x, where x is a Poisson random variable. Its expected value is given to us as half. Now, you need to recall that parameter for Poisson random variable, we call it lambda, and that is the expected value and as well as variance of Poisson. The probability mass function for Poisson distribution is e to the power minus lambda, lambda to the power x, if we are looking at fxx, upon x factorial, okay? Where x can take what values? 0, 1, so on and so forth. So what we have is that expected value of x is equal to half, and lambda, that means is half. So therefore, our PDF is e to the power minus half, half to the power x upon x factorial. Now we need to figure out expected value of x plus 1 factorial. So that will be summation x plus 1 factorial, where x goes from 0 to infinity. E to the power minus half. Expectation we all know. Expectation of, say, function of x is equal to summation the function of x into fxx, okay, over all the x's. So it will be x plus 1 factorial, e to the power minus half, half to the power x upon x factorial, right? Now we can open up this factorial. We know that x plus 1 factorial is basically x plus 1 into x factorial, e to the power minus half, half to the power x upon x factorial. So x factorial cancels. And what we get is summation x plus 1 e to the power minus half, half to the power x. X is 0 to infinity. Okay, so this is what we have. Now, e to the power minus half, I can actually just keep it outside because it is not, part of the summation, as in it's just a scalar value which can stay outside. Let's keep that outside, and we have summation. X goes from 0 to infinity. X plus 1 half to the power x. Here, what I'm going to do is I'm just going to do a simple substitution. I'm going to take x plus 1 as, say, y. Okay. So when x is 0, y is 1. When x is infinity, then y is also infinity. So your summation becomes, see, it's never equal to infinity, is tending towards. Equal to infinity is nothing. I mean, it's just that it's just an expression to understand that, okay, it's moving towards infinity. We don't know what exactly is infinity. So we generally say tends to. Any which way. So here you have this summation becomes y, summation of y, half to the power y minus 1, where y goes from 1 to infinity. Okay. Y goes from 1 to infinity. Now let's only consider this. Let me just consider this. Let's take this as S. So s is equal to, start giving values to y. So it's going to be 1 half to the power 0 plus 2 half to the power 2 minus 1, that is 1, plus 3 half to the power 3 minus 1, 2, and so on and so forth, right? That is, s is 1 plus 2 into half plus 3 into 1 by 2 square plus 4 into 1 by 2 cube, and so on and so forth. Can you see what's happening here? This is an arithmetico-geometrical series. So it's called AGP. It's a combination of arithmetic and geometric series. So here in the denominator, you can see that the powers are increasing. So it's behaving like a geometric. And in the numerator also, there is a constant increment of 1, 1. So it's behaving like arithmetic as well. So this is AGP. The trick to solve an AGP is figure out what is your common ratio. So common ratio clearly is half. So what I'm going to do is I'm going to multiply this sum by half. So half s will be, now in the denominator 1 power of 2 will increase. So you will get half 2 upon 2 square plus 3 upon 2 cube plus 4 upon 2 to the power 4, and so on and so forth. Now the next step is subtract this half s from s. So s minus half s. Now when you're subtracting, what will you do? You will subtract the like powers. So we will not touch 1. We will subtract 2 into half minus 1 into half. Like powers in the denominator. Subtract that. So you will get 1 as it is, plus 2 minus 1 will give you 1 time half. Now 3 upon 2 square minus 2 upon 2 square will give you 1 upon 2 square. Similarly, the next one will give you 1 upon 2 cube, and so on and so forth. So what is happening with this is that you get a normal geometric series. That's the whole idea of solving like this. So this is a geometric series, infinite sum we have to find out, which will be a upon 1 minus r. So 1 upon 1 minus half, which is equal to 2. So that implies half times s is equal to 2. That implies s is equal to 4. Which means, now let's go back to the summation. Let's go back to expected value of x plus 1 factorial. That will be equal to e to the power minus half into s. S turned out to be 4. So 4 times e to the power minus half. Let's now go back to the options. Do we have any such option? Yes, option B. So option B should be the correct answer for this question. I hope you understood, and with this question, we were able to actually revise a little bit of series as well. So I hope now you go back to, again, like finding expectations, go back to how to work with factorial questions, go back to how to work with geometric series and arithmetico-geometrical series. Okay? Thank you. I hope this helps.